Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video, and by the end of it, I hope you can solve problems using exponentials and calculus. So here we're talking population of a town is given by this function here. Y is the population after X years, and we're going to find how quickly the population is increasing after 10 years. So we did exponentials last year. You probably remember exponential growth is characterized by a quantity growing at an increasing rate. So if we're talking about exponential growth of a population, the population might increase by 100 in the first year, by 150 in the second year, 230 in the third year, and so on. The number of additional people entering the town is increasing each year. Each year it's going up by a little more than it did the previous year. If we were to just draw a quick graph, so this town would have a population starting at 20,000 and it would grow up like that. The population would get pretty big pretty quickly. So when we're talking about the rate of population increase, how quickly it's increasing, hopefully straight away you're thinking calculus, because calculus is a rate of change. If this is the population and this is the time, then the rate of change of population with respect to time is just dy dx. So all I need to do is differentiate this function here. So hopefully you remember from previous videos that to differentiate something that has e to the power of something, what we do is we leave the e and the power alone. So I'm just going to write e to the power of 0.05x. That part stays the same. So also if you have a constant out the front, that stays the same. So when we're differentiating the e's though, you need to remember to multiply by the derivative of the power. So the power is 0.05x. The derivative of that is just 0.05. So I'm just going to times 20,000 by 0.05. And this is the derivative of that. So I left the 20,000 alone. All I did was move the derivative of the power to the front and leave the e and the power alone. Of course, 20,000 times 0.05 is just 1,000, and this is an expression for the rate of change of population at a given time. So now all I have to do is insert different values of time, and it will tell me how quickly the population is changing at that time. So x is the number of years, so after 10 years, x will be 10. So if x equals 10 dy dx, all I do is substitute x for 10. I get 1,000 e to the power of 0.05 times 10. So to the nearest whole number, it's about 1,649. So at the instance, exactly 10 years after we've started our little study here, the population is increasing at a rate of 1,649 people per year. It's per year because x was in years. So again, this is an instantaneous rate of change. It's just the rate of change at a particular instant in time. It's not the whole rate of change over the whole 10 years or anything like that. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.